climate crisis is a result of humankind essentially polluting the atmosphere with greenhouse gases from burning of fossil fuels over the past 150 years. That has led to record-breaking heat extremes around the world, severe droughts, wildfires, extreme flooding episodes. The time frame for addressing the climate crisis is here and now. We're already living on borrowed time.
Passive House is a system that started in Germany, and what it means is that we are optimizing all of the systems from the thickness of the walls, the quality of the windows, the orientation of the building, the air tightness of the whole envelope. The ultimate goal being building homes that just don't require a lot of energy to operate.
Love Schack is approaching this project based on our principles of environmentally friendly, ecological construction and reducing carbon footprint.
So the building in Wilson, Wyoming is really interesting for a number of different reasons. I think the architects and the owner and the builders have all kind of worked together to understand both the architectural design side of this as well as kind of the building science side.
We explained that in order to qualify our contractor, we would require that person to go get some training. The homeowner is a pretty incredible person and said, well, what if we brought that training to our builder? And what if we not only trained him, but we trained his crew? And what if we trained and invited our building code officials, our city council members, anybody that wants to come, that wants to understand about better building science? What if we did that?
Here in the Teton region, there's someone who's doing a project of his own for his own passive house and really saw education as the pathway to making that happen. And what's really important about that is that in order for any of these projects to happen, you really need to have an ecosystem of professionals that know what they're doing and are all starting on the same page. We have probably about 15 builders here today learning about the passive standard, so it's like building to code. It's just that you're building to this higher standard.
So if you look at the bigger picture and making housing affordable, making the total cost of ownership low for people that are going to own their buildings, and at the same time making something that is going to do an impact in a positive way for the environment. The philosophy that we follow here is buildings are for people. The passive house standard has been used for over 25 years. It's proven in the field in different countries of the world, different climate zones. It works, and we see a lot of people that are interested in just doing the right thing, whether they are the homeowners or the builders.
Even over the years of building to the standards that I've been trained to and the industry has had out there and the codes have been saying we have to build to, we're still finding problems. We're still finding problems of mold, air infiltration, and durability. So it's been intriguing for myself and my crew, and we've learned a lot.
If we look at what the climate models are suggesting for the Teton, Wyoming area, it is more of the same, more of these extreme events. And so we are on this path for the worst case scenario. The best case scenario would be backing off on our input of greenhouse gases into the atmosphere, and what we call bending the curve, actually then reducing the amount of carbon dioxide in the atmosphere and then reverting to our weather and climate patterns of decades ago.
It's generally considered that buildings between their construction and operation are responsible for about 40% of the CO2 that is generated on an annual basis. The solutions are the ones that you see every day, really. They have to do with where does the electricity come from? It has to do with transportation, mobility. It has to do with buildings. So all of those things are the main pieces of the pie that creates our energy problems today.
The site where we're building is really, really special. The greater Yellowstone ecosystem is one of the most temperate ecosystems in North America. We have to be really responsible not only to wildlife, but to the whole ecosystem of what is there. And what would be the goals of a structure like that, and could we reach them in a place like Wilson, Wyoming, where we're in one of the most challenging climate zones of America?
We are using a very new material called cross-laminated timber for both framing and finish. Sometimes we like to incorporate, where we can, materials that connect us back to nature.
Cross-laminated timbers, I have not worked with them before. They mill them and they glue them together so they are one solid piece of wood. And then the windows are cut in, the doors are cut in. Now the fun begins and we start screwing them together.
Because this is a panelized system, the walls went up very quickly.
We were fully enclosed in 8 working days, and because there's adhesive in the lambs, it already sets itself up well for sealing. So once you get this whole diaphragm together, you're already at an air tightness that's superior to, say, a framed construction.
All these different rating systems are about how to understand how buildings affect the environment. How does the building affect the site? How does the building affect water use? How does the building interact with the landscape?
Part of the effort is to minimize combustion in the whole project. So I think the client's going to understand that we're not doing a lot of toxic activities inside the space, you know, like machine shop stuff, like toxic paints and stains, welding. The heating systems that are going on that are exposed have very small loads. And because we're already within the threshold of Passive House, it's just like easy, no-brainer, we're meeting our standard there. And then ultimately what that all leads to is like, this is still a really low energy building.
These are all our plumbing. We got our recirc going on in here, lighting in here. So this is being dropped a lot further. I have this planned to be dropped in wood. I mean, so this is what has to go up behind that bookcase with me, 2 of these. So anywhere there's a living space, you've got fresh air coming in. Anywhere in the bathrooms or hallways, things like that, you've got exhaust air going out.
You want to have air that's consciously brought in to where it's needed and filtered and then also exhausted, but in a way that doesn't actually reduce all of that heat. So we want to basically be able to recover that heat using an ERV or energy recovery ventilation system.
So the insulation is happening on the outside. We're using a combination of some rigid mineral wool insulation, and then we're using a Gutex, which is a wood fiberboard insulation, which does have a negative carbon impact.
We're going to have an envelope that will be somewhere around 18 inches thick, which will give us, I believe, a total exterior envelope of an R60.
It's really exciting right now because the plastic's been coming off, more insulation is going on. As you can see behind us, there is a window in place.
One of the unique things about a lot of the glass that comes from Europe is it can be fine-tuned to the job site, so you can change things like the solar heat gain coefficient. So here being a cold climate, they want kind of the free heat from sun coming in, so they'll have a higher solar heat gain coefficient to let more of that UV energy into the house to heat it passively.
This garage door is unlike any other that we've ever designed. Not that we design a lot of garage doors,
Right.
but in this instance it was kind of critical to the success of the airtightness of the whole building.
Probably the most high performance garage door in the country or the continent. I don't know.
We needed a way to seal and insulate a 12-foot by 12-foot opening. Schweiss made the frame, which is basically a hanger door frame. And then Andy Olred, he built the panels that go on it so that we've got expanded styrene panels that sit on the outside, 6 inches of that. The Swice door allows the center straps here to pull the door tight into our weather stripping so that it air seals it. It's a unique system. When the windows are all in and everything's taped, then we can do a blower door test, and that will be the true test of what the air leakage of this house is. The county requires a 3, and we are shooting for a 1 or less.
I focus on building science consulting and performance testing that goes along with it. Here today to test the air tightness of the building through blower door testing and look for air leakage with thermal imaging. For this building, right now it's looking at going for low energy building under the Passive House standard, which is 1 air change per hour at 50 pascals or less. And then true Passive House is going to be like 0.6 air changes per hour at less than 50 pascals. And so we're looking to be ideally under even the true Passive House, but for sure under the low energy building at 1 air change per hour. So looking pretty good so far.
7.6. Yep.
Right, we get a little bit of thermal
at the bottom,
which is to be expected.
Green building has continued to get better and better over the years, and we've really recognized that it's not simply a matter of solar energy, it's actually a matter of its environmental impact for water, for air, and so forth. So it's really much bigger. And in the last 10 years, the issue of embodied carbon in building materials has come to the forefront. It's probably 10% of our overall emissions globally, and it's one which we can actually address quite easily. So the idea of being able to use building materials that have a lower embodied carbon content has become something which is required by the federal government and is becoming more commonly required at state levels as well.
So, results, 0.36 air changes per hour. So, very good.
That was way beyond what we expected.
Super tight. 0.6 is full Passive House air tightness, and they're almost half of true Passive House tightness, so it's awesome.
That's awesome. That's amazing.
Wow.
So we got to give Steve the good news.
Good job, builders.
And tell them how good they did.
I know. We can't wait to tell Steve and Alex they did an awesome job.
Yeah.
Big good. Overhead door at 0.36 is bonkers. It's great.
It's great. Very good. Yeah.
Oh my gosh. We're pushing ourselves to not only create something that performs as an object and is beautiful, but also has a performance metric and an experience on the inside that is, tactile and that people really can attach to and believe in. But we hope that by having this project be an example, that we're going to show that not only is this possible, but it's within reach and it's appropriate.
In order to deal with the climate crisis, really at the heart of it is dealing with carbon. And so decarbonization means moving off of fossil fuels and turning to alternative energy sources, renewables, hydrogen, modular. Ultimately, we really want to bring that wedge of carbon dioxide consumption down to as close to zero as possible.
So there are a lot of benefits for the homeowner and for the investor. It's going to be less operating costs. It can be actually less expensive to build. It can be more durable, and it can have high health benefits in terms of having less sickness and better environmental quality for the occupants. Buildings are not that complicated. I would like everybody to know that you can go out there today and retrofit your building to become a zero energy building and help the climate in the process.
The primary purpose of pushing Passive House is buildings can be so much better than what the minimum code compliance delivers today. This is the way to the future for construction.
The real future of building is going to be in an overlap where the passive standard is used as the kind of framework of a building code, and then we really make some efforts on the materials side to get to natural materials that are less intrusive on the environment as well.
We have to educate a culture that is based a lot on cost effectiveness. But it's not just the client, it really is the building industry and the building culture. In my opinion, we have to remain open to change and do what we can today so that we're building better houses for tomorrow.